Do you want to see me rewrite this in Rust? Do people want to see that? Is there any interest in that? If not, I won't be offended. But is there any interest in me writing this in Rust? Because we can compare how fast it would be. I could probably go through and do part 1 and part 2 in Rust. Sure, Rust is nice. Yeah. Okay, I'm convinced. Let's make a new one called Rust Impl. All I've done so far is cargo new Rust Impl. That's all I've done. So we will cd into Rust Impl. We'll vim rust format.toml, and we'll put this in here. Max width of 80 and use small heuristics. This is how I like to format my code. So let's do a nice cargo build on this and let it compile for the first time. There we go. Cool. So now what can we do? Let me remember how to do anything in Rust because it's been a while. Source main. Yeah, cool. Let me think about how I want to approach this. Okay, we have example. Okay. Source main. Okay. Let me pull in some crates, actually. Cargo, add, anyhow. This is one of my favorite crates. It just allows me to do really, really basic error checking. Sounds like you're rusty with Rust. Clever. Let me tell you this. Context switching between Bash and Rust breaks my brain because the environments are so different. But I'll get back in the Rust mode. I write it a lot. I write it on a daily basis, so don't worry about it. I'm okay here. All right, so what we can do here is use anyhow results, and this just gives me a nice result type that I can return from my main method. So now I can just return okay. And this will allow me to do very easy error checking in Rust by just being able to put a question mark in my main method. So the first thing we need to do is we need to read the file. Let's just pull in fs, which is the fs library. I think it's fs read to string, and we need to read the file into the string. So let's say contents equal this. We do need to get arguments. How do we pull out environmental? Is it user? I'm gonna make up some syntax before I Google it. I think it's standard env, and I think you can do let args equals env args. I don't know. Let's go ahead and compile this and see what happens, because the chat says it. Compiler is my friend. 100%. This is absolutely true. Argument is missing. Oh, right. Yeah. Let's just make sure args is right. Yes. Okay. Args is right. So I think we can do env1. Print line. I think we can do args. Let's just see what I'm pulling in as an option of a string. Okay. Need file as arg1. Cool. All we're doing is we're pulling out, I can't use context because I have to pull it in. We're pulling out the first argument. So this program, instead of reading it from standard in, this program is going to read it as the first argument. That's just easier for me to write here. Okay, so now we have args. What happens when I run it? Cargo run -q example input. Cool, so it just found the argument. Perfect. So we'll call this file. We will read that file into contents. And now we should have, if we print the contents, we should have that exact, we should have the contents of that file. Now let's just format it nicely. We need a question mark here because this can return a result, because this operation could fail. Hey, look, we've read the file in, and we have a trailing new line because we use print line, which adds a new line, and the file already had a new line at the end of it. Cool. So now what we can do, let me remember how to do this. For line in contents dot lines. I think lines is a method. Print line. I think this is right. I just spelled it wrong. Yeah, lines. That's what I was picturing, but I just wrote it incorrectly. Hey, look at that. Now we're reading it line by line. Let's create our grid system here. So let mut grid equal a vec of a, vec, and we won't set it equal to anything. So the compiler doesn't know what this type is. We're going to let it infer this type by us loading things into it. So let's comment that out for now because the compiler will yell at us. We have lines, and we want to split it on nothing. So for C, which is character, I think we can do line.split on nothing. I think this works. Don't quote me, but we're going to find out. Empty character literal. Yeah, it's... Oh, because it's a character literal, it has to be character. I think I give it a string. There we go. So now we are looping over it character by character. We may have to do some trimming here. What I mean by trimming is, yeah, we might have some empty lines that are being processed, and we don't want that. So I think... Does it have trim? I think it has trim methods. There we go. Still looks wrong, but we'll deal with it when we deal with it, right? So reading the file in, let mut width equal 0, let mut height equal 0. The grid is a vec of a vec. In here, we will create a new thing. We'll call this row. And then we will do grid.push row. Cool. And then we will do row.push C. And then we'll print line whatever the grid is. So this should be the entire two-dimensional array. You see how nice it is to have a language with two-dimensional arrays? So have I lost anyone yet, or are people kind of following what's going on? I realize I'm moving quickly, but hopefully I'm kind of doing a decent job explaining. So yeah, we have these empty things, and that's not great. Why are we having empty characters? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, having an empty character at the top and the bottom is not ideal. Where are those coming from? I feel like trim should trim them all off, right? Am I crazy? Can you use line.chars? Oh, yeah, that is a method, isn't it? I think you can. Yeah. I think you're right. Thank you. I forgot that was a thing. Oh my god, that's so much nicer. That's so much nicer. Now they're actually characters instead of just strings. Yes, thank you. I can use that. And I am using that, and it's beautiful. So now that we have these set, we can do width equals... let's do height first. Height equals grid.length, which is .len, and width equals grid spot 0.length. This will blow an assertion if there isn't a 0th spot, but we're going to assume the input is good, so that should be there. So now we can print, let's see, puzzle height equals this, height. Width. Okay. Cool. We're good. What did part 1 do? I literally don't remember what the puzzle was. She walked around and we had to figure out how many distinct places she visited before she left the puzzle. Cool. That's what she did. So we need to make her walk around. Let me look at the bash one so I can remember exactly how I accomplished that. Oh, I accomplished it. Ooh, wow. I haven't looked at this code in like an hour. Oh man, I don't know what's going on. Oh yeah, this is where we try to move her in a direction. Okay. So we can do some cool stuff here. We can make an enum. How nice is that? Look at this, and we don't have to check for an unknown one because Rust does that for us, which is so awesome. Rust is such a great language. I love it so much. Oh, while we're here, we should also find out where the guard X and Y is. These are the guard coordinates. If C equals this character, then we know it's the guard. So then we can set the guard coordinates to the X and Y of where we are. But we don't have the X and Y because we haven't been counting it. That's annoying. Probably a better way to do this, but here we are. There we go. So now we should have the guard coordinates at that. Let's go ahead and print those. Guard coords equals, and there's going to be some ways I can clean this up. Okay. Guard coords at 4 and 6. Is that right? She is 0, 1, 2, 3, 4. So she's 4 down, and then 1 or 0, 1, 2, 3, 4, 5, 6. Yep, that's exactly where she is. Let's do some, what are enums again? I forgot. Enumerate. Yeah, basically that's what they are. So this thing is direction is an enumeration. So it has these 4 constants. You can just sort of treat them like things. I could say like, let direction equal, this is not valid code because I'm not in a function, but I can say like let direction equals direction : up. And then I can like check down here if direction equal direction down. The beauty of this is they're not like a string or some sort of underlying data structure. They are just this, I think Rust calls them zero cost abstractions. They just exist in the code, but they can get compiled out or compiled into a really optimized way. So they're just super nice way of that. Let's see. Please do a video about moving stuff around in Vim. How do you copy and paste indent so fast? I will do that. I will do that. I'll give you the quick lesson. Shift V. I'm moving up and down. I'm highlighting lines. Copy with Y. Y is for yank. Delete with D. D is for delete. And then hit P and just paste it back. So that's the quick, super fast version. So for anyone paying attention, I can do the enumerate method on this because this returns something that's iterable. So when you have an iterator, you can call .enumerate on it. And now it returns 2 things, the number, which was Y, and the line. I think I have the order correctly. I think it returns the number first and then the data. I think it does number first and then the data. I could have it backwards, but I think this is right. And I think that's what you wrote in your example. So if that's correct, then I can just do this. Oh, right. So because I used enumerate, they returned a U, an unsigned integer, and I'm using -1 here as a placeholder. Let me teach you a quick lesson about Rust, okay? This would be called a sentinel value, -1, meaning this is a special value. That means it's not found, and Rust doesn't like when you do this. So instead, what we are going to do is we are going to set this to none, which is an option type. And then down here, we're going to set this to sum, meaning that we found a tuple of what we were looking for. Then down here, we can do something really beautiful. Guard coords equal guard coords dot unwrap. Uh-oh, could not find guard. So this is really cool. I think this will work. Let me just double check that I'm not making up syntax. Oh, unwrap doesn't take a string. My bad. Unwrap doesn't take a string. If you want to use the function that takes a string, it's expect. So I typed the name in wrong. Oh, I did. Guards coord. Yeah, guard coords. There we go. I just had the wrong variable name in there. So now we run it. We still get an error. Cool. Oh, right. I want to unwrap it to not be an option. That's what I want. So I don't want to mutate it. I want to do this. I want to create a new variable. I want to shadow it. Need let again. Yes, exactly. Yeah, I just realized that. Cool. So this is the very rusty way of doing it, where we set this thing equal to none, and then if we found it, we set it equal to sum. In fact, we could even like assert here that guard coords dot is none. And that's our way of saying like, oh, hey, we only ever want to find one guard in the puzzle. If we find more than one, something's wrong. So now down here, we can ensure that in 2 things in this line, we ensure that we did find guard coordinates, And now we made this new variable with the same name, so we shadowed the previous variable, but this is just set to the tuple of coordinates that we found, not the option anymore. So we can deal with it just with, you'll see how I deal with it later. But yes. So now, yeah, we have some warnings because I have unused variables. That's okay. But we can see puzzle height equals 10, puzzle width equals 10, and we know exactly where the guard is. Hey, that is so awesome, right? So let me pull up part one again. I just want to remind myself of my actual flow. What did I do once we have all that stuff? We kept track of what we've seen. I'll worry about that later. I'll add that later. We just go into a loop of trying to move her. Okay, so let's do that. So we're going to try and move her. Let's go into a loop. While true. Actually, we're in Rust. Loop. We can just use the loop construct. There is just a construct in Rust called loop. Very nice. So, try to move her and see what happens. So we know the guard coords, and we want to have, let's say, let new coords equals something. Oh, this is so cool. This is so cool. Oh my god, I love Rust. I really do love Rust. Like, I love Bash because it's so niche, but I love Rust because it's so clean. You ready for this? Let new coords equals match direction. So we haven't done this. We haven't initialized her direction. We should do that. Why did I do this? What am I thinking here? What is this? What is this? What am I doing? Sorry. We can get rid of those mutts. We don't need them to be mud. We just set them here, and then we're fine. Now I totally forgot what I was doing. Oh, we need to initialize her direction, right? So she starts going up. We know that. So her direction is set to up. We are going to be able to modify this, though. So we are going to figure out her new coordinates by looking at her current direction. If it is direction up, then her new coordinates should be her old coordinates with her y set to a smaller number. This is an interesting thing. Let me think about this. Because I'm using the enumerate function, the coordinates will be unsized integers. And then if we subtract from it, we're not going to get a negative number. We're going to get a very, very large positive number. So I think we're going to need to use a Rust function. I believe Rust has a function that lets you add or subtract from a number, but check to see if there would be an overflow in the process. Because this is low-level stuff. Your CPU is what can determine that by setting the flag for that. So I think we'll have to do that. This might not be as clean as I want it to be, but let me mess with this. Yeah, because it would be guard coords dot 0 and guard coords dot 1. And this one's the y one, and we want her to move up, so we have to subtract 1 from it. I'm going to write this like this for now, but this will have an issue with overflowing, so we will have to use checked variants of these commands. Sounds confusing, but I'll explain it when I actually bump into it. So now I've just copied and pasted that 4 times. Direction down. If we're going down, then the y value goes up. If we're going left, then the y value goes down. And if we're going right, then the y value goes, or sorry, the x value goes up. I don't remember what I said. Ignore what I said. Look at what I wrote. So yeah, I think we'll have to use some sort of checked variant because we're going to get into a heap of trouble when it overflows. But let's worry about that when we get to it. Print line, trying to move her from 2. Cool. This is debug print notation in case anyone's wondering. I can't just print a tuple directly as a string, so I have to print it, I have to debug format it, and that's how I do it. Guard coords, new coords. Cool. And then, yeah, we just seem to do this in a loop. And let's just run this. And it's going to be wild. We're going to cargo format. We're going to format the code. Oh, look, there's a syntax error. Yes, because we did let here. Cool. Cargo run. Okay, and we never actually set it. Right. Cool. So this is a lot cleaner. Yeah. So I cargo formatted the code. That's why it looks slightly different now. So now we tried to move her into this direction. We need to check at the new coordinates if there's going to be some sort of collision. So the grid is in YX format. So we'll have to check current character equals grid Y and X. So Y would be new coords dot one, comma, nope, new coords dot two, because we're using a two-dimensional array. So we'll grab that from it. What's going to happen is this is going to crash eventually once we get out of bounds, and that's when we'll deal with it. Let's assume, let's just move her here. And the way we move her is by saying guard coords equals new coords. I think I can just do that, right? Oh yeah, unreachable statement because it's an infinite while loop. I did dot 1 and 2. Yeah, I'm stupid. Dot 1 and dot 0. Yeah, so this would be X. Cannot assign twice to immutable variable. What does that mean? That's what that means. Cool. Here we go. So we did try to move her. We moved her in all these directions. Attempt to subtract with overflow. Yeah, so there's a way to do this. I think it's like, does anyone remember off the top of their head? I guess it'd be aneurysm who would know. Is it check sub and check mul and checked? I think it's like check sub, checked add. I think it's just a function. Let's just make up some syntax and see if it works. Don't forget about awk. It's fast. Listen, man, I believe you. I think it's checked. I think you do this. Checked sub 1. I think it's that, and that returns a result or something. Yeah, it returns an option. Okay, cool. Okay, yeah, it's check sub and checked add, and that will return an option. If it's some, then it was valid. If it's none, then you created an overflow. The nice thing is here, if we create an overflow, then we know that we're out of bounds. So the beautiful thing here is we move this. We move this into a function, and then we can return early from the function. Function get new coords. I don't know. Who cares? Coords is a tuple of a U something. What do you think it is? A U64? A U size. It's a U size. That's what it is. Which probably is a U64 on my machine, but that's neither here nor there. Option of a U size. Yeah, that's what it returns. So the beautiful thing we can do here now is we want to take the coordinates and the direction. No, we're returning a U size, and let's take a pointer to this. Okay, I'm gonna cargo format real quick just so it looks nicer. Okay, so we have a function called get new coords. It takes two things: a pointer, a reference of the original coordinates, and a reference of the direction we want to move in. So now we can just do this. There we go. Cool. And now, because we're using check sub, we can just put a question mark here. Checked add. And we just put a question mark here. So if you're confused as to what's going on, instead of subtracting them using the subtraction, like the minus sign or the plus sign, we're using these functions because these functions can fail. And the way they fail is if you're going to create an overflow scenario. And the beauty of that is that the way they fail is they return an option with either none or some. So we can just forward that option through this. So we can just use the question marks here. Now, if this function returns none, then we know that she tried to walk out of bounds. And then we can basically just break out there. Let me just not worry about this right now. Try to move her. Let new coords equals get new coords, and it takes the original guard coords and the original direction, and then we should match on it. So we'll do let new coords equals match this, and if this returns sum, then we just save it to that variable. If it returns none, then we will print line she walked away, LOL, because we're out of bounds, and then we will break from the loop. That's what we will do here. So what happens here? We expected an option. Oh, okay, right, yep. This whole function expected an option, so what we can do here is we can just do boot sum here and sum here. There we go. Cool. So now we can see because she tried to walk out of bounds, she walked away. Now, she didn't actually walk out of bounds. We just don't have collision detection, so she just kind of left as quickly as she could. So we need to actually handle collision with her, which is super easy. So now that we're trying to move her there, we know that both of these are in bounds. Let's see. If we can match on C, if it's a period, then we know that she's moving in a way she can move. If it's a pound sign, then we know that she hit an obstacle. And if it's anything else, then we panic because WTF is this, because we shouldn't expect anything else. There we go. Rust is so beautiful when it's written right. Oh my god, I really do love this language. So, if it's a period, then we want to try and move her there. And the way we do that is by swapping the two coordinates. We don't try to move her there, we do move her there. So grid new coords dot 1 new coords dot 0 equals her character. And then we have the guard coords. These were the original ones. They get set equal to a period. And then we do guard coords equals new coords. So this should handle moving her. And then now we need to handle collision. So if there's collision, we need to rotate her. And the way we rotate her is we just change her direction. Direction equals match direction. And look how beautiful this code is going to be. You ready for this? This is my favorite thing. If she is facing up, then she will face right. So we're just rotating her clockwise. That's all we're going to do with these. We're going to handle all 4 possible situations and point to what her old and new one should be. So if she was facing right, then she should be facing down. If she was facing down, then she should be facing left. If she was facing left, then she should be facing up. Let's see. And then what happened here is we didn't do any bounds checking because we only checked the bounds in one direction. That's what we did. We only checked if she walked away going out the bottom or the right of the puzzle. We didn't check to the left or the top of the puzzle. So here's what we can do. Actually, we should put it in new coords because new coords checked if it was, no, we shouldn't. We're going to check it down here. So basically, we only checked if there was an overflow. And if there was an overflow, sorry, let me rephrase this. If we check if there's an overflow, that means she went to the left or she went up, which would have been in the negative direction. We need to check if she went too far. So if new coords dot 0, which is the x, is greater than or equal to the width, or new coords dot 1 is greater than or equal to the height, then print line, she also walked away, LOL. Break. There we go. So that's it. Now we're moving. We are moving. Now we need to keep track of every place she has ever visited. And the way we do that is we create another one of these. So we have a grid. We'll call this the scene grid. How many places we have seen. So scene row, scene grid dot push scene row, and then we will say scene row dot push false. Yeah, this is fine. So we're making a 2-dimensional array, associative array, where we will associate an X and Y coordinate with a Boolean value. We'll default all of them to be false. And then whenever she moves to a new coordinate, we will set it equal to true. So if we got here, she was able to move to new coordinates, then scene grid, guard coords dot 1, guard coords dot 0 equals true. So now we keep track of all the places she's seen. We have that. Now we just get the length of scene down here, and we're done. Scene blank distinct places. Scene grid dot len. There we go. Scene 10 distinct places. Was that right? Where's part 1? The guard will visit 41 distinct places. So we have this wrong. Hash set of you could totally do that. Yep. Yes, 41 is correct for the what I should be seeing, and I'm seeing 10. So that's correct. Incorrect. You could definitely do a hash set. Hash set's a cool thing for anyone watching. You can just put things in there and it will automatically deduplicate it for you. So the way that I'm using Booleans here for this two-dimensional grid is totally just doing what a hash set could do. So let me go ahead and just use a hash set. Is it standard collections? I think that's where a hash set. I think it's standard collections, right? This is how I program. I don't really even like look stuff up. I just kind of wing it. Scene row. Scene row. Let's get rid of all this scene stuff. Let's do scene equals hash set new. And then we don't even need to give it an explicit type because we can just create it here. Scene dot insert. I think it's insert. It doesn't matter which order we do these in as long as the order is consistent. I think we can just do that. And then we can just call scene on this. You're right. Okay, so what was happening with the old thing? I called the len on it, which of course the len was 10 because it was a 10 by 10 grid. I needed to actually iterate over there and find all of the ones that were true. Instead, thank you aneurysm, you just use an hash. Thank you aneurysm, what a wild sentence. We just use a hash set. So a hash set, I'll show people what it looks like at the end. If I were to print that hash set out, pretty print it, put the pound sign in that debug notation, you get pretty printing, it will look like all the places that I visited. So it just keeps track of everyone I placed. And if it gets inserted in there multiple times, it gets deduplicated automatically because it's a set. The underlying data structure will handle that for you. So yeah, good call. That was the right way to do it. So let me cargo format this. Let me go here. Let me remove that. Cargo Clippy, make sure our code is good. There are two things that are not good. Unneeded return statement, right. I don't need this. Implicit return if you omit the semicolon as the last line. And we're good. So let's go ahead and run this. We should see 41 distinct places. Awesome. Let's go ahead and give it the real input. And if we look at this, your puzzle answer was 4433. So let's go ahead and assert that this is the case. 4432. 4432. What is happening there? Why am I off by 1? I'm going to be honest. I did not expect that to happen. Why am I off by 1? That is wild. Oh, I know exactly why I'm off by 1. You got it. Starting place. In the original bash code, yeah, I'm off by 1 because I didn't include the starting place. In the original bash code, look at this. I keep track of her starting place right when I create the data structure. I think we got lucky in the example because I think she walked over the starting place, so we recorded it the next time. I think that I don't think. I know exactly that's what happened. So here, we should keep track of the coordinates immediately. That's what happened. Oh boy, yep. That's exactly what's going on. It was a starting position 4433. If I pull up the original page, 4433. There we go. That's it. I would love to do part 2 of this problem, but I don't want to. I'm burned out. I'm tired. I've been streaming for almost 3 hours, so I'm going to call it a night here. Let's move rust impl to rust part 1, cp-r rust part 1 into rust part 2. So now we have a whole second directory where we have what will be rust part 2. And if I remember correctly, I think it works like this. I think we just compile it. Yes. Okay. So this was our rust solution. So let's see. So what was 2 again? I have to go refresh my memory of what puzzle 2 was. I think we had to we had to add all this concurrency stuff. We have to put what we did is we did the complete brute force solution. We put obstacles everywhere on the map and then checked to see if she got in a loop or if she got out. And the way we detected it in a loop is if she visited the same spot going the same direction. That's guaranteed to put her in a loop. So let's go here and see what we have. This was our thing to get new coordinates. This is our thing to move her. Okay, cool. So we have to keep track of... we have a grid. We need... Do I have a hash set? I do. These were all the places she had seen. Do we need to keep track of the places she had seen? No, we didn't actually need to keep track of the places she has seen in part 1 because what we're looking for in part 1 is how many different positions could you choose for the obstruction to stop her. So where we keep track of what she's seen, we're going to also keep track of her direction. It might yell at me. It might yell at me because I don't think it can take ownership of that. Yeah, we'll have to derive hash on it, and I think we'll also have to derive clone on it. Oh, EQ, because we need to compare equality. My God. Rust. Let's go. Oh, right, we inserted in 2 spots here. So let me also insert here. I really think it's going to yell at me because I can't own it. Yeah. So what I need to do is I need to derive clone on it, and then I might need to put a star in front of it. Oh my God, when you've written enough bash, you can just, or not bash, when you've written enough rust, you can just see that coming from 8,000 miles away. Let's just do .clone here, and then .clone here. They're enums, they're pretty nothing to clone. There we go. So now we are keeping track of every place she has seen, and the nice thing is we have to double check when we move her. So here's what we have to do. Let me remember how to do this. If it's a period, we are going to move her there. And we swap out the location, so this actually moves her in the grid. We set her coordinates here, and then we've set that we've inserted it. Now in Rust, isn't there like a checked insert? I think there's a way to like check if you've inserted or if inserted worked, but I think we can, what we can do is we could just do this. Let, I don't know, value, or tup, because it's the tuple of these. We're going to save this key here, and that way we can just insert the tup here. But I think we can do, I think what we can do is we can say if scene dot contains tup. First we'll check to see if it's there. If it's there, then loop detected. And we'll have to do something when a loop is detected. I don't remember what it is right now off the top of my head. That compiles. So now we have loop detection method or functionality. So let's see, we do a loop, we do a match. Yeah, this would break her out of the loop. So we can detect if we have seen a loop. Let's test this the same way we tested it last time I did this, if I remember correctly. I think the way we tested it before is we modified the example input and we added an obstruction here. If I put an obstruction here, then she will force herself into a loop, right? No, next to her. If I put the obstruction here, then she will get into a loop. Loop detected. Okay, cool. So we were able to detect that loop. So now we have a way of detecting if she walks away or if it's a loop. Cool. So now what we have to do is we have to test a whole bunch of different maps. So we have to take all of this logic and we have to put this into our own function. So we'll make a new function called function test map. I don't know, we'll make our own map. We'll take some arguments and we'll return I guess map has loop, and we'll return a Boolean, which will be true if a loop's detected and false if a loop is not detected. I think that's what we'll do, because all we have to do is we have to count all the ones that created a loop. So we read the file in, we create the grid, we get the guard coordinates, and there we go. I think we have to save all this stuff. Okay. We're going to take all this logic and we're going to move it up into map has loop. And then we're going to take our arguments here. So we're going to check to see if this map has a loop. So what do we need? Well, we need the grid, and this will be a vec of car. Was it a car data in there? I think it was character data. We need guard coords, which is a tuple of U sizes, and then that might be it, but we'll mess around. We can get these all from that. Cool. Can Rust have inner functions? I don't know. I don't think you can have a function with a function. I could be wrong. I'm not as good at Rust as I am at Bash. What a wild sentence. I don't know the answer to that. You can have closures. Rust definitely has closures, and you can do like sort of like you'll see like syntax like this, stuff like that. I don't know if I can just define a function in a function. My code's not going to compile right now as is, so I'm not even going to try. Okay. What did I call it? Map has loop. So let has loop equals map has loop grid.clone guard coords.clone. These are going to yell at me because I don't think they're clonable, but we're going to take the easy way out and we're just going to clone them. You can assign a closure to a variable, which is similar. Yeah, I'm pretty sure you can do that. Yeah, but it's not like I don't think I can use the FN keyword not at the base level of indentation. I just don't think that'll work. We're going to modify this grid, so I need to declare it as mutt here. This will also need to be mutt. That just worked. There's no way I just wrote that right on the first try. Panicked. That's what I thought. Oh, not yet implemented. I think I left the to-do in there, didn't I? Yeah, okay. So if we got to the bottom here, there was no loop. And if we got up here, there was a loop. Cool. She walked away. She walked away. Okay, cool. Okay. So now, let's get rid of the trying to move her. Print. Okay. So now we have to loop through every single possible puzzle. And the way we do this is we have to grab the width and the height, so we know how many to do it with. Get the width and the height of the puzzle. And then we will do for y in, what's the y value? Height. I think you can do, is it 0 ... height? I think that is valid syntax. And then for x and 0 ... width. I also think that's valid syntax. We'll find out. Cargo build should just tell us. Yeah, those are valid syntaxes. Okay, cool. For y and x in these, we will check if grid x, y equal a dot. Then we will change grid x, y to an obstacle. Let's just clone it right now, so we won't mess with the original one. A lot of cloning here. This could definitely be cleaned up. Does this work? That works. Okay. So we're putting an obstacle into place if there's a period there. And then we will test if it has a loop. Let total loops equal 0. Make that mutt. If has loop, total loops plus equal 1. And then print line here, have loops. Okay. And then we can do a nice little print here. Print line testing x comma y as obstacle. And then do we have any other print lines that really matter? Testing this an obstacle if it has a loop. No loop. I think that's okay. Let me remember this. Let me think about this. Okay, so this went through and tested the example input, tested all these puzzles, and then it determined that 6 of them have loops. And if we go over here, the example input, there are 6 different positions you could choose. So this logic should be ready. We should be ready with this logic to go ahead and test the real input. Now, if you remember, I never let the real input finish on Bash until we added the concurrency. I went through and added it up later. When I looked at the concurrency of it, I took the timestamp of when I started and when I finished. It took about 5 minutes and 10 seconds. So the Bash version with concurrency, what did I do? The max concurrency of like 10 or 50? I think I did 50. Max concurrency of 50. That took 5 minutes, over 5 minutes. Oh yeah. I think -- release is the way to go. I think you're right. I am curious. Let me do a cargo build and a cargo build -- release so we don't time this. Oh, there is a -- timings. I don't even know what that does. Let me do some testing real quick. What is -- timings? Probably doesn't do anything with -q. I just thought I'd put timing at the bottom. Yeah. Because I do want to time it. And then if we do -- release, I do want to see like debug versus release. Cargo build, cargo B. All right, so now we're going to get ready to do the regular input. And I think, did we take it as an argument, the file? I don't remember. Yes, we are giving it the argument. Okay, cool. So we don't have to recompile, which is nice. Let's go ahead and run this with -- release. We are still outputting the name of the puzzle we're testing, so there is going to be some slowdown from us outputting the terminal. We can get rid of it, but let's do this just to get an idea of how long it will possibly take. It is so much faster. Of course it is. Of course it is. But wow, it's like, it just... 11 seconds. And the answer it gave me is 1516. And if we go over here, Your puzzle answer was 1516. So, yeah. 11 seconds with zero concurrency. Zero concurrency. Like, I don't have any Tokyo tasks or anything being spawned. I am curious how much slower debug would be. That seems a lot slower. Like, I can count that number on the right going up. Oh, man. Didn't even need Rayon. Yeah, exactly. Oh, I love Rayon. I use that in... I wrote a program called VSV, which is for Void Linux. It's like the Void Service Manager. And I used Rayon in that. And, oh my God, I remember because I run it on my Raspberry Pi. It'd be so slow, one after another. And I used Rayon. I was like, this is magical. How crazy. Like, this is just crazy. Oh my God. So yeah, debug and release definitely made like a big difference here. Oh man. Yeah, because this one's going to run for a while. I wonder how long it'll take. But 11 seconds in release mode is just pretty awesome. Like, pretty awesome. Wow. I don't even know how many there are. Okay. Okay. That's not the worst thing in the world. 1:08. It took 5 minutes in bash with concurrency. So like, okay, not the end of the world here. Let me do some quick testing here. Let me just get rid of these. Don't even let it try to print. Cargo B release, run, release. Oh, it's still printing. Right, because I have a non-print line macro there. Let's build it with release. Run it with release and timings. See if it goes any faster, not having to run to my terminal screen. It probably shouldn't. We're not going over SSH or anything. I'd imagine it'd be like 10 seconds. I have a gift. What can I say? 10.9, so basically 11. Honestly, that's like variability that like probably wasn't even the prints that did it. So yeah, for people who are interested in my Rust solution, that's how I would do it in Rust. And oh my God, it is so much faster.